All right, in this question here, I'm going to teach you how to solve a trig equation that yet again does not involve using the unit circle because our solutions are not going to be special angles. So within our domain here, 0 to 2 pi, so be very wary of our radians, we're working with radians here. And then state the general solution. So by general solution, I mean state all the solutions possible. So looking at our equation here, we have 2 tan x plus root 5 is equal to 0. First thing I would do is actually isolate tan x. So I get 2 tan x is equal to negative root 5. And of course, tan x will therefore be equal to the ratio negative root 5 over 2. So let's go ahead and draw a xy axes to find out where these solutions could be. Now, our tan ratio here is negative. So using add sugar to coffee, we need to identify where could we have our solutions. So using add sugar to coffee here, or the casserole, our tan ratio will be negative in 2 spots. It's going to be negative in quadrant 2 and in quadrant 4. Okay, so what's really special about these two angles is they'll also have the same reference angle. So our first solution is this angle in radians, which I'll call x1, and our second solution is our angle in the fourth quadrant, which I'll call x2. Once again, they have the same reference angle, so this angle right here is equal to this angle right here. Okay, so let's find out what that angle is. We're going to go back to the equation and find out what is the reference angle. To find the reference angle, I'm going to take the tan inverse of positive root 5 over 2. The reason why I'm taking the tan inverse of positive root 5 over 2, not negative, is because reference angles are always positive. So we want to take that positive case. So going into the calculator here, let's go ahead and solve for that. So we'll go make sure you're in the right mode first of all. We're in radian mode. And then we'll go second tan, and we're going to put in root 5 over 2. So let's see what measurement we get in radians. And we get 0.84 radians as a reference angle. Okay, now we can't say that's our solution. We have to go back to the diagram. So this angle right here is 0.84. And this other angle right here is 0.84. So we're going to use that reference angle to find x1 and x2. For x1 here, you'll see that x1 is from the positive x-axis to the second quadrant. So to get that rotation angle, we need to take pi, which is equivalent to 180 degrees, and subtract 0.84. Okay, so let's go ahead, go back to the calculator here, and just go second function pi, find that pi button. Okay. Oh. Okay, and then subtract your answer. Okay, so our first solution is 2.30 radians. Okay, so 2.30 radians. And let's find that second solution, which is in quadrant 4. So to get a rotation angle in quadrant 4, we take a full rotation, which is equal to 2 pi radians, and we subtract the reference angle. So we're going to go 2 pi minus 0.84. And that will give us our second and last solution between 0 and 2 pi. Let's go back into the calculator here and go 2 pi, subtract 0.84. And we get a second solution of 5.44. Okay, so I have two solutions here. So go ahead and box those here. And the last thing we need to do is go ahead and state the general solution. So for every trig function, remember from graphs, it repeats itself over and over and over again. So for the first general solution here, here's my first solution, which was at 2.3 radians. That's going to repeat itself over and over and over again, right? But more specifically, these have the same reference angle, so it keeps going every 180 degrees. So our general solution here is going to be equal. There's actually two ways you can express it here. Okay, so you can start with x1 and say it's going to repeat itself every pi radians. So our first general solution is 2.30 radians plus multiples of pi radians. And to show multiples of pi radians, we use the letter k, where k can represent any integer because it can go both in the clockwise and counterclockwise direction. You can also think of it as starting at this angle right here, which was 5.44 radians. So it repeats itself over and over and over and over again every 180 degrees actually. So a second way you can actually state your general solution, and this is also correct, is going 5.44 radians plus multiples of pi, and we use k to show that, where k once again is a member of the integers because we go in clockwise and counterclockwise direction. And that's how you do that question.